As I mentioned in my earlier video, finite element analysis is a broad subject, and fitting everything in one course is next to impossible. In this course, we will look into structural analysis using finite element analysis software. In structural analysis, we are going to discuss only linear static analysis, which means that the stress-strain curve remains at a constant slope irrespective of the load imposed on the structure. In this course, we are going to make use of software Salome Meca for generating geometry and meshing it. Then we are going to use efficient software to generate a command file that will direct Codester software to conduct finite element analysis on the mesh that we previously generated. Once we obtain results from Codester simulation, we are going to use the inbuilt Paraviz module of Salome Meca to evaluate results. First, we are going to do a very quick three-dimensional analysis of a cube to show how easy it is to conduct finite element analysis in Salome Meca. As the command file is a core part of finite element analysis, in the next case, we are going to edit this command file and add gravity load to the beam and see how easy it is to edit command files. Next, we are going to do a one-dimensional analysis of a cantilever beam and compare finite element analysis results with hand calculation. Then, we are going to take this one-dimensional analysis and conduct a two-dimensional analysis using beams. When geometry is cylindrically symmetric, we can use axisymmetric mathematical models and conduct finite element analysis, which we are going to see next. In several cases, when the third dimension of a structure is very small compared to other two dimensions, we can conduct finite element analysis using shell elements. In the next analysis, we are going to conduct a full three-dimensional analysis of the same geometry that we used for shell analysis and compare results. Till now, we have been using three-dimensional tetrahedral elements. In the next analysis, we are going to use three-dimensional hexahedral elements for a finite element analysis. Linear meshing is adequate for some analysis, but for advanced analysis, we need to create a quadratic mesh. This we are going to see next in the analysis where three-dimensional quadratic meshes will be used to conduct finite element analysis. In the real world, many different components join to form an assembly, and as such, we need to carry out finite element analysis on an assembly. In the next case, we are going to conduct a pseudo assembly analysis, which is quicker than running an assembly analysis. Next, we are going to run assembly analysis, which will consider all different components and how they join and what are the equations to be used for the join. Well, we have a very long distance to cover from the exhaustive list I just mentioned. So, let's get started.